Good morning, Tahmina Khan is here. In this video, I will explain to you the past paper questions of logarithm equations, functions, and this is the topic of O-level Add Maths. Code is 4037, which is a syllabus of CAIE. In the previous 4 videos, I have explained or built up the concept which we will apply in these past paper questions. So if you do not know those all laws and rules, so please watch the videos first so that this video make more sense to you. So before I begin, you can see here on the top is written my blog address, tkmathsisfun.blogspot.com, which has the link of all my previously made videos, and this is the email address tkmathsfun@gmail.com, so you can send your query on this email address. So first question I have picked up is from November 18, variant 2-3, question 6. So question is saying solve the simultaneous equation. So you can see two equations are here. Solve means you have to find out the value of x and y. So we need to change, or we need to remove log somehow. So let's see what do we do. So first equation, which is this one, I'm calling it first, calling it second. So if I change this equation into index form, it will become this whole thing equals to 2 power 3. So this is what I have done, and 2 power 3 is 8. So I got a simple equation without log which has x and y in it. Now I will change this equation into just xy so that I can solve these two equations simultaneously. Okay, so now if you see here, both the terms have base 2, right? So I am applying here what? Quotient rule, right? So 3x divided by y. So it is log 3x divided by y power 2. And then I'm changing it into index form, which is this whole thing equals to 2 power 1. And then cross multiplication. So I got equation 1, x plus 2y equals to 8. And equation 2, 3x equals to 2y. And I will solve it simultaneously. By the way, this is not just the only way. There are more ways. We can change this 1 into log 2 base 2. But I'm not taking that approach. So it's up to you. Okay, so here are the two equations and we will solve them simultaneously. I think everybody at this stage is able to solve equations simultaneously, which are just linear equation, very simple. And you will get the value of x and y. So I'm just showing it to you, or you can try it yourself in your copy because it's a very basic thing at this stage. So I got the values of x and y. Okay, so now let's see November 18, variant 1-3, question 5. Now this says show that log 4 base 9 equals to log 2 base 3. So what comes in your mind? Think about it, recall all the laws. Okay, so I'm picking up left hand side. So because I have to show that this is equal to this, right? So I'm picking up left hand side. After that, what I will do? I want log 2, right? So instead of 4, I'm writing 2 square because 2 square equals to 4. And then what will I do? I will apply power law. This 2 will go here, right? Okay, so now I have 2 times log 2 base 9. What I have to change it equals to? Log 2 base 3. And I have base 9. So what comes in your mind? Change of base rule, right? So I want base 3. So just to help you recall it, remember we studied earlier that log b base a can be written as log b divided by log a with the base of our choice. For example, here it is c. So exactly the same thing I will do here. I will do log of 2 divided by log of 9 with base 3, right? So I am applying this change of base rule, which was this in this situation. So I have gotten the base 3 here. Okay, so after that, now here I can't do anything. So let's do something here. 9 can be written as 3 power 2, right? So 2 will come here as a multiplier. This 2 will remain outside as a multiplier for the whole term. Okay, so after bringing this 2 down here, now you have log 2 base 3 divided by log 3 base 3 and multiplier of 2 here. So these two will cancel out, right? If you take it out, it is 2 divided by 2 basically. And this thing is equals to 1 because log of a number with the same base is 1. We have studied this rule also. So this is exactly what I got, which was on the right hand side of the equation I had to prove. So I have proven. Now the part 2 of the question is saying hence. Whenever the question says hence, it means you have to make use of the part given earlier, right? So let's see what is the question. So question is saying hence show that log 4 base 9 plus log x base 3 equals to 3. And we have just proven that this part is equals to this. So I will replace this whole part by this. You can see here from part 3. Now here I have two terms with the same base 3. So I can apply product rule, 2 multiply by x, which I am doing here, right? And after that I will change this log form into index form. So it will become 2 times x is equals to 3 power 3. And then simple algebra, I got the value of x, which is 27 power 3. Common mistake is student take it as 3 3s are 9. It's 3 power 3. So please be very careful while you are solving equations. Now this question I have picked up from November 18, variant 2 to question 4. Now question is saying solve this. It is this. So when the question says solve, it means you have to find the value of x. So how can I bring this down? By applying power law, right? And by applying power law, I need log on both sides, otherwise power law will not be applied. So that's why I'm taking LG on both sides. You can take ln also, choice is yours. So this whole power will come here as a multiplier. And after this, you know, basic algebra, LG2 will go down here, right? You can get the answer. And then simple algebra -1 will go on the other side and then divided by 2. So you got the value of x. Okay. So next part 2 of the same question, log y plus 14 base 3 equals to this. Now what comes in your mind? Question is saying solve. It means you have to find the value of y here now, right? Okay, so this term has log base 3. This term has log, not base 3, but it is log. And this term has no log. So if I want to solve y, I need to have log in each term so that I can apply product rule, quotient rule or something. Or there is other way. So what I am doing here, the approach I am taking this term in the numerator. When this term will go in the numerator, number become base, base become number. You can see here. I will show you this little later. So it is 2 times log y base 3, right? Change of base rule we are applying, which was this. If you have log in the denominator and you take in the numerator, number become base, base become number. The same thing I am doing here. Okay, so second thing what I am doing here, I want a term with log here, right? So I am multiplying this by log 3 base 3. What other thing you can do, I will show you in a while if you don't want to do it like this, right? So after this, I have 3 terms and each has log base 3. You know, na, log of a number with the same base is 1. Okay. So now what I'm doing here, this side, after applying power law, which will become log y square base 3, I will have 2 terms with the same base here, right? And then I will apply product rule. This term I'm just writing as it is right now. So I'm applying a product rule. So 3 will multiply by y square. And now 1 term on each side of equals to, so I can remove LG3. Now students make mistake at times. They just remove LG3 from here, here and here, and they write y plus 14 equals to 3 plus y square. You can't do that. You can do only this thing when you have 1 term on each side. Okay, so don't make mistake of removing it from this stage. So it is y plus 14 equals to 3y square, and then it will become a quadratic equation. Okay, and you will solve it. Let me show you. Okay, so this is the quadratic equation we have gotten, and we are factorizing it, which we usually call middle term breakup. We are breaking this up into 2 terms, and we have gotten 2 values of y. Now the log function, if you remember, was what? It was this. It was this, right? So, and the answers of y you are getting are -2 and 7 upon 3. So if I write here -2, log will not be defined for negative number, right? So that's why, though it will be defined here but not here. So in the equation, the value should define the whole equation, all term, each and every one. So that's why I'm writing y equals to -2 is not possible, right? So only y value is 7 upon 3. Now let me tell you, when I was talking about here, okay, this is not just the one way of solving it, right? Here I was multiplying 1 by log 3 base 3. So other way of solving it is that you bring the term which was here on this side. Let me show you here. We have solved till here, right? So if you have done this step, like you are taking this LG3 base y here on the top and you keep 1 here, right? You keep 1 here. So you take this term to this side and keep 1 here. So this is how you will solve it then. Okay, so 1 is here, the term has come over here, and then I'm taking 2 up here. It will become power law, applying power law, and then quotient rule, because base is same and 2 terms will be divided. And after that I am applying or changing log form into index form. So this whole thing equals to 3 power 1, and then I will get the same quadratic equation which I have just solved, right? So it is up to you. There are 2-3 ways. Whatever you want to approach to you can do that. Okay, this question I have taken from June 18 variant 1 to question 9. Part 1 of this question was very simple. It was saying solve log x equals to 3, which means the base is 10. So very simple one line solution. X is equals to 10 power 3, which is equals to 1000. Okay, so the next part of the question was saying write this whole term log a minus 2 log b plus 3 as a single logarithm, right? So now to change this into single logarithm, I should have log in each term so that I can apply power on power rule, quotient rule, product rule, whatever. This is not an equation, right? It is an expression. Remember it. Okay, so what I am doing, this has base 10, this has base 10. So I am multiplying 3 by log 10, because log 10 is equals to 1. It means log 10 base 10. Clear? So after that I am applying power law here. It will become b square, and power law here. So it will become 10 power 3. So now the minus sign means this will divide and these two will multiply, because product rule have plus sign and quotient rule minus sign. So it will be log 10 power 3 times a divided by b square. So this is, you have changed it into single term. Now for the same year, June 18 variant 1 2, the question we have just solved, this is part B of the question. Now it was saying solve. So this is a simple quadratic equation. When we will take LCM, it will become x square minus 5x plus c. So simple quadratic equation, cross multiply, 0 times x is gone. So you are left with this. You do middle term breakup, factorization, and you get 2 values of x. So you get full marks in this part. Wow, great. So why this simple question is given here? Let's see part B of this, which is saying hence. Okay, hence showing all your working for the values of a such that, okay, so this is given to you and you have to find the values of a, and it is saying hence. It means we have to make use of the part 1. So let's start. If we see here and if we see the previous part, I'll just show you here in a while. Here it is base 4, here it is base a. So if I take this term in the denominator, keep the 6 up here in the numerator, so this will become log a base 4, right? Now if you compare this form with this form of part A, is it same? minus 5 plus 6 plus 6. These two terms are same, and in part 1 what was written here? X. So this is exactly what was given in part A, but instead of x you have this. So it means if the value of x whatever is equals to, that is equals to this part also, right? So that's why when I say x is equals to this, it's not wrong, it's perfectly okay, because this whole thing is equals to x. And what are the values of x I have found in part 1? 3 and 2. So let's substitute the value of 3 and 2 here one by one. Okay, so first I'm applying the value of 2 here in place of x, because we have just seen that x is equals to this. So after that I will apply what? Yes, index. I will change this log into index form, so it will become a equals to 4 power 2. So I got one value of a. Now I will substitute the second value of x, which was 3, and then again I will change this log form into index form, so it will become a equals to 4 power 3, which is 64, right? So this is how the simple equation is solved using the answers of part 1. Now let's see June 17 question 22. Means variant 22 question 7. It is given to you that a power 7 equals to b, where a and b are positive constant. So find this log b base a. So what is given to you? A power 7 equals to b. So what I'm doing here, I have to find this out. I will try to find out the connection between these two. So I'm taking log base a on both sides. Okay, because at least then this term will become what? Log b base a, what is exactly like this. So I'm taking on both sides of the equation, because I have single term. Remember, single term. If I had plus something minus something, I could not do this. So I'm taking log base a on both sides, multiplying both of them, right? So now I will apply power law. 7 will come here. So log of a number with the same base equals to 1. So 7 multiplied by 1 is 7. So I got the answer of this. Okay. Okay, so let's see part 2 of the question. Same question. So this is saying log a base b. And what was given here? A power 7 equals to b. So now if I change this into this form, because I have just found the answer of this in part 1. Can you see here? This was equals to 7. So if I take this whole in the denominator, I will have log b base a, and then I'm using it, because you know when it is written like this, part these, so it means they are all connected, right? They are all under the umbrella of this question. So I do not need to do all over all these steps here. I have just proven it here, so I'm picking up the value, so it is equals to 1 over 7. So it is same June 17, and question part B saying solve the equation. So if you look at this question, solve mean I have to find the value of y, so I do not want this here. The only way to get rid of this is to change this log form into index form. So I will write y is equals to 81 power minus quarter. And after that, simple indices rule and common sense I'm applying. 81 can be written as 3 power 4, right? And then if these two multiply, it will become 3 power minus 1, which is equals to this. You can also do one thing here, take this whole thing in the denominator, for example. So you can take whole this in the denominator. Let me show you here, like this. The power will become plus, and this means 4th root of 81. You can use calculator and find the value. So I'm doing it here without a calculator. You can use, and if you are strong in multiplication tables, you will remember this thing. Now this question, last question of the video. So I have to solve this equation. So what comes in your mind? What will you do? If I change all these numbers 16, 32 and 4 into base 2, what it will become? 2 base 5 is 32, 2 base 2 is 4, 2 base 4 is 16. So instead of 32, I am writing 2 power 5, not base, 2 power 5 multiplied by x square minus 1. And I am writing 4 as a 2 power 2, which is multiplying by x square. And after that, I'm applying law of indices. When bases are same and there is division between the terms, we subtract the power. So you can notice I'm subtracting this whole thing minus this. Now, exponential equation says if you have one term on each side of the equal to sign and they have same base, you can equate the powers. So I'm equating the powers and then I'm solving it. I got x equals to plus minus root 3. So with this I will end my videos, and in next video of past paper question I will take a little challenging question. Basically challenging is what a student find difficult. This is my belief. So at times very simple thing becomes a challenge for some people, and very challenging question a student do very easily. Thank you very much for watching this video. If you learned something from this video, please press like and subscribe button, press the bell icon. You will get the indication of my new uploaded videos. Take care. Allah Hafiz.